Alright, today I'm going to be talking to you about graphing derivatives and antiderivatives from graphs. I think there should be a colon here. It's the Mega Review. So this is another lesson I'm doing by popular demand. If you wanted to get the most out of this lesson after the first few slides where you're brushing off the dirt, you should really pause every single slide, even on the first few maybe, and do the problem yourself first on paper, so you can't lie to yourself and say, oh yeah, that's what I was thinking. After that, then you should go ahead and watch my solution. If you're not doing that, you're just watching some person do calculus. And I'll do it pretty well. It's pretty late. My skills are fading, but here we go. So, when I'm going to graph the derivative of a graph, which is the f prime graph if I'm starting with f, or the f double prime graph if I'm starting from f prime, it's all about estimating the slope at a point. So if I was going to graph this guy's slope, if I was going to graph the slope, because the idea here is if I'm graphing the derivative, is slope of f. And in this unit, it becomes really important, if you remember from the lesson, it becomes really important that we're talking about slope of what? Of who? Whose slope? F's slope. So what I notice here is there's a couple key points. I'm going to look for the slope of 0. So I'm going to box the places where slope is 0. We're going to do that throughout this lesson. That's a 0 slope. That's a 0 slope. How do I know? Because rel, max, or min. On F. On F. So they become x-intercepts over here. So specifically, baboom, baboom. Alright, and that leaves a few other points. So, I don't know, you're just trying to draw some tangent lines. You're either good at this or you're not good at this, and I'm okay at it. And I'm better at drawing on paper than I am on the computer. See what I mean? Jeez. Get it together, Leven. Alright. So I would say this slope is about slope of 1. And by 1, I of course mean negative 1. Yes. And then it just all becomes about connecting the dots here. So I would say this is some sort of positive slope. In general, all of these slopes are negative, and then positive slope again. So we're just going for some sort of curve. It's a solid dot at like 3.5. It's another solid dot at positive 3.5. And we're just connecting all these things. Like so. And that's all there is to it. Solid dot endpoints, you better have solid dot endpoints. End of story. That's all there is to it. It's really not that difficult of a skill to graph the F double prime from F prime or the F prime from F graph. Graphing the derivative should not be the difficult part. Alright, now for the difficult part. So you're going to make an F prime number line. This is going from F prime back to F. We're going to make an F prime number line using location or position of the points on the f prime graph. Does not involve the slopes of f. We're going to make an f double prime number line using the slopes. Combine the information to form a graph of f. So, the idea here is that for f prime, a box now the box will mean an x-intercept, right? Because that's where it came from. I'm going to put a blue circle around rel max min. And again, just remember this of f prime. Because that would mean that on your boy f double prime, he would have x-intercepts. Because slope of f prime equals 0. So we're getting x-intercepts. Because we're talking about f double prime equals 0. Slope of f prime is f double prime. Okay. Now the x-intercepts of the f prime graph will actually have nothing to do with the f prime graph. But this line will go the other way into your other function, f. The x-intercepts here had to come from rel max min. Actually, not rel max min. Let's call it what they are. Critical numbers of f. Possible rel max or rel min. Okay. And then these are the possible points of inflection of f. Okay, and that just means possible points of inflection. They might not be points of inflection. We'll have to analyze the data. That's the connection. That's the overview. If you really understand this table I made on the fly, then you really can do this lesson no trouble at all. Here we go. So I look at this graph and I'm going to make some f primes. I'm going to make an f prime number line. I'm going to make an f number line. Bingo, bango, bongo. Where are some x-intercepts? So again, box x int of f prime. Okay. Bing, bang, boom. Okay. But the only interesting one being 0. What are we going to write down here? Now, before 0, f primes, the sign of f prime will be the y value minus. Those are based on sine of f prime, right? Just like always. Y coordinate. And then my possible points of inflection in my blue circle would be negativo dos and positivo dos. And I'm putting brackets because it can't go past there. Before that, the slope based on sine of f double prime equals concavity of slope f prime equals concavity of f. So that's relating to these two. But you know what? I'm just going to throw it on here just to make this table super duper clear. Here we go. The sine of this guy's y coordinate right? X-intercept is a certain kind of sine. It's a very special kind of sine. The f prime's y coordinate will tell you whether f is increasing or decreasing. This is why this is the culminating lesson. It tells you nothing about f double prime. And then the most interesting case is the concavity connection here is the same as the slope of f prime which is the sine of f double prime. Okay? Now the orange and the blue, light blue that I just added, do relate. Really do relate to the red. It's the same basic idea. Here I go. Oh, not doing it. So the slope here was positive because we're talking about f prime increasing or decreasing. Okay. F prime's increasing, then decreasing, then increasing. So putting that all together, if you want to use those guidelines, up and then down, concave up, down, concave down, then up. Starting point 0, 1, right there. Concave down, inflection, concave up, solid dot endpoint, concave down, inflection, concave up, solid dot endpoint, increasing, decreasing. Done. Try this out yourself. Pause the video. Try it out. Try to do your best to come up with both of these graphs and then come back to me. 3, 2, 1. Did you pause it? I hope so. Here's an x-intercept. So it's a possible critical number. It's going to go on my f prime number line. It should be over here. Let's do. Okay. Any places I see slope is 0? Nope. Nope. Anyway. So what I notice is that this line is a line. Lines always have constant slopes. The slope of this line happens to be +1, right? So if the slope here will become the y coordinate here. So if the slope is always 1, then the y coordinate here is always 1. Boom. Up until 0. Now what's the slope here? Sharp turn. No slope. So it's not there. And then what's going on here? And it's kind of hard to tell. Except maybe you would say the slope there is 2? I don't know. Maybe you would say the slope here is sort of like a, almost like a relative maximum. And then it's increasing linearly. And now, I mean, we're kind of using, oh, gross. I don't know why the pen's acting dumb. See, like that. I did that fine. We're using kind of our knowledge that this looks parabola-ish. So its derivative should look 2x-ish. But it's not that important. F double prime is always more lenient. They're usually not asking you. It's just about reading graphs and practicing this. You should see how many FRQs come up on this, guys. It's crazy. Okay, now the sign of F prime before -2 is definitely negative. Look at those y coordinates, all negative. After, the y coordinates are all positive. There is a sharp turn at 0. There is a sharp turn at 0. It was a possible point of inflection, but actually the concavity changed. The slope here, the slope of F prime, is positive, and it remained positive. So now I'm going to have decreasing, increasing, concave up, concave up, and it hesitated for a second. This is at 0, by the way. Hesitates for a second at 0, but then stays concave up, with maybe an ever so slight hesitation in that you see it's increasing at an even faster rate than before. So here I go. We're just paying special attention to -2. Concave up and decreasing. Concave up and increasing. Just so it doesn't look symmetric. And again, no one's going to give you a hard time. Probably should have arrows. It's probably not going to kill you. Alright, let's warm up. This is a good warm-up question. Play the matchy game. The top row is a graph of f. The bottom row is a graph of its derivative. Pause the video. 3, 2, 1. Alright, let's start with the easy one. 26. Slope equals 1. Always. Hey. I'm just going to circle them both in pink. Blue. Alright, so this guy, the slope is negative, then positive. The slope should be negative, then positive. This is the only one where the slope would be negative, and then the slope would be positive. The slope of f is negative, then the slope of f is positive. The y coordinate of f prime is negative, and the y coordinate of f prime is positive. Okay. Always positive slope. Always increasing. The y coordinates are always increasing. The slope of f is always increasing. The y coordinates of f prime are always positive. Last but not least, I don't know, this pink? They're all ugly. They ugly. These two have to match. Does that make sense? Positive slope, increasing, decreasing, increasing. Positive y coordinate, negative y coordinate, positive y coordinate. Done. Sketch a graph of the derivative. Pause the video, do it. 3, 2, 1. What do I notice when I look at this guy? This guy's slope is always, oh, not 1. Up 3, right 1. So f prime always 3. Means y coordinate of f prime graph always 3. Which is that kind of graph. It's that easy, folks. F prime's easy peasy. Pause the video. Try it. 3, 2, 1. Okay. So in keeping with the tradition, this is a special point. That's where the derivative was 0. That's where f prime equals 0. The slope equals 0. So over here, it's where the y equals 0. Wow, okay, except it's over here at 1. And if you really felt, particular about this, you could sit here all day and night sketching, oh, I don't know what that is. The key thing is, the slope is negative, the slope is positive. So we're looking for something that's a negative slope and then a positive slope. A negative y coordinate and then a positive y coordinate. Sorry. Now, here we go. I'm going to go with this one. I'm going to say this slope looks like about 2. They can't penalize you. That's how easy it is, guys. They really can't penalize you. There's no way to do it. So we just have to trust you guys to do your best to model it. Oh no. We're only going to go out to 4. Shoot. My B. Okay. Goes out to 2, 3. Solid dot. Solid dot. That's all they're looking for. It shouldn't be bent at all. I just can't draw a straight line to save my life on this computer. You're like, on this computer, please, Mr. Levy, you can't do it in real life. And I'm like, well, come for tutoring sometimes. I'll draw a straight line on your paper. I'll draw a straight line so good. You won't even know. There you go, that was pretty good. 3. Pause the video. Try it. 3, 2, 1. What do I notice here? Oh my gosh. M equals 0. Always. Y equals 0. Always. So it's a... Did the screen get brighter for you? I'm not going to search for this video to find it, so I don't know. Email me? Okay. Yeah, so that's all it is. Done. It's just a horizontal line at y equals 0. Next. What's going on here? Try it out. 3, 2, 1. The slope on this side is 1. -1. Sharp turn. Undefined. So I should be looking at a line like this. +1. Open circle with an arrow. -1. Open circle with an arrow. Done. Finally, the interesting thing. Please try it out. Here we go. 3, 2, 1. Okay. X-intercept. That means it's a key point on my F prime number line. Specifically, it's the place where F prime goes from positive to negative. This is the graph of F prime. You mustn't forget. Now, F double prime. What's going on here? What's the slope? It's always negative. What's the slope of F prime? It's always negative. So, always concave down. So here I go. Increasing, decreasing. Concave down. Concave down. Local max. Starting point 0, 0. Boom. Concave down. Concave down. You want to touch the boundary. That's the standard. That's it. That arrow could be a lot nicer. That's good enough for me. Graph it. 3, 2, 1. 2 x-intercepts you should notice off the bat. They're going to be key parts of my F prime number line. -1, +1. With hard boundaries here at -2 and +2. F prime goes from being negative. This is the graph of F prime. I'm talking about the y coordinate when I'm talking about F prime now. Goes from being negative to positive to negative. So that's in my F prime number line. How about my F double prime number line? How about that slope? Wow, I'm sorry if it's knocking. Try to tighten it up. The slope of F prime goes from being positive to negative with a flip at 0. Positive slope. F prime is positive slope. F prime is increasing. F prime is negative. F prime slope is negative. F prime is decreasing. Happy, sad. down, up, down, concave, up, inflection, concave down. Starting point 1, 2. Graph that point first. What's happening at 1? Oh, it's a maximum. So I know it had to look like this. Concave down, decreasing. Inflection. Concave up, increasing. This has to be a relative min, right? Look at the shape. Done. Should probably be a little more symmetric than that. Graph it. Try it. Put your pencil on the paper and try it out. Pause the video and try it out. Don't lie to yourself and say, oh yeah, that makes sense. You need to be trying them, not just watching me. 3, 2, 1. Did you pause it? Did you try? One more shot. 3, 2, 1. X-intercept. X-intercept. Okay, let's go. Bam. Arrows, because arrows. -1. +1. F prime is negative. F prime is positive. F prime is negative. Undefined slope. F prime slope. F prime slope is positive. F prime slope is negative. Okay, here we go. Down, up, down, concave up, concave down. So what I'm going to do to recognize that it's a bad point is I'm going to show not a vertical tangent, but what else would have an undefined slope there? What else? Who else would have an undefined slope at 0? What other kinds of graphs can give me an undefined slope? So we're really talking about a slope, a graph whose slope is always negative. I'm sorry. A graph that's always concave down, concave up, and a graph who's always concave down. So it should look like this. Ow. Sorry, I kicked myself. Oh, let's start the graphing point. Sorry, starting point. -1, 2. Right here. Okay, so. Okay, this has to be a local minimum. Concave up and increasing. Now something special is happening at 0. What's happening at 0? I'm gonna say Just a sharp turn like that. Alright, now I'm gonna use my rule and say you have to make a, touch the edge. That's kind of dumb. It's good enough. If you're working on your own paper, you don't have all this. Okay. A sharp turn there. What else could be acceptable? I think they could have to give you... No, they can't. No. Okay. Like an open circle there. Give me a second, I need to drink water. I don't think they would accept the whole. After thinking about it some more. I don't think they would accept the whole. Why? Because it has to be differential at that point. Because the slope at that point is 1. The slope at that point is 1. It just is a weird looking thing. I don't know. Derivative graphs can be weird. It's okay. Alright, here we go. This should look very familiar. X-intercept. 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 Now these endpoint x-intercepts aren't as important as the others, because we can't really tell what's happening on the other side of them. F prime is negative though. Whoa. F prime is positive. Zero slopes. The slope of f prime is 0. The slope of f prime is negative. The slope of f prime is positive. The slope of f prime is negative. So here I go. A lot of students have this weird tendency to go up and then down. That's not decreasing though. Just go down. It's okay. No one can mark you wrong if you do it right. Take that to something like that. Starting point 0, 0. Oh, I was supposed to do that in black. I'll do it in black. I'll show you. Inflections at 1 and -1. Stop. Inflection. Stop. You don't have to over-exaggerate your inflections. Just do it however feels natural to you. Did you try this out? Did you have time? Here, I'll take a nice long break for this one. You better try it out. You're not going to get better watching me do it. Just try it. Draw it on paper. Highlight the key points. Okay. There are no x-intercepts. Weird. Oh wait, no. Arrows. Arrows. There's a key point though here. At 0. Undefined. Okay. But it's positive before that. F prime is positive before that. F prime is positive after that. Now what about the slope of F prime? That's also an important point to worry about. Before that, the slope of F prime is 0. After that, the slope of F prime is positive. In fact, it's 1. But that's happy happens to be. Okay. Usually we do something like that because we're thinking this might be a asymptote. Okay. Now, an asymptote might not be the most likely of graphs. Maybe it's just a sharp turn, which is very likely with the straight line piece here. So we're probably going to say it is a straight line up until that point. Because an asymptote, we would expect the slope to be getting infinite. And then a concave up. Okay, now you'll have a tendency to make this happen here. I'm going to make it happen here just to make it clearer. I need to have a slope of 2. This slope equals, sorry, the y coordinate there. So therefore the slope of this piece has to be 2. And you better believe I'd look for that on your test. It's something that you should fairly easily understand. And concave up, increasing, like that. Now, there's no way to really know if this was a jump or not. If this graph is not continuous, this graph does not have to be continuous. That's the way to say it. If this graph is continuous, this graph should be continuous. Okay? This graph is, yeah. That's right. Something like that. Now this could be shifted vertically. It's okay. Up or down, but the key point has to happen at 0. Halfway done. Oh no. Okay, that was me doing a graph of F. That was me doing a graph of F. Ah! Here's me doing a graph of F double prime. I forgot these are the ones of 2. Okay. M equals 0. M equals 2. 1. Yes? M equals 0. M equals 1. Weird, right? That's all there is to it. I didn't give you a long time to think about it. I didn't realize what I was doing. Okay. On all the other ones, I'll do it the right way. So first I'm going to do a graph of F double prime. I should use a different color for that, huh? Then I'm going to do a graph of F. Okay, so follow along. Try both on a separate sheet of paper. I would have done both, but I forgot what I was doing. It's late where I am. Alright, try both. We're going to do a graph of F prime, F double prime first. This is a graph of F prime. This is a graph of F prime. Make a graph of F double prime. Make a graph of F prime. 3, 2, 1. Okay. Important parts. Now this will be more important on the other one. But these jump out at me for obvious reasons. But for F double prime, for my F double prime graph, those will be the most concerning. Because those are the places where M equals 0. The slope of F prime is equal to 0. So this guy has x-intercepts. Oh. I'm just now noticing this doesn't have 6. It's very unfortunate. Oh well. And then I would notice that this guy, his slope goes from positive to negative to positive. Oh, this is both. Sorry. Slope is positive, slope is negative, slope is positive, slope is negative. Okay, here we go. Slope is positive. Slope is negative. Slope is positive. Slope is negative. Right. Done. Something like that. Perfect. Okay, same key points. Rel maxes, rel mins, x-intercepts. So you should have made an F prime number line with arrows for -6, 0, and +6. Because the graph of F goes from negative to positive. The graph of F prime goes from negative to positive to negative. Down, up, keeps going up, and then down. F double prime, we just graphed F double prime. You can go read its graph if you wanted to. But the key points here are -4. Notice how I'm lining up the tick mark halfway there. +4. And also 0. So the slope goes from positive. The slope of F prime is positive. The slope of F prime is negative. The slope of F prime is positive. The slope of F prime is negative. Concavity of F. Okay, here I go. Concave up and decreasing. Concave up and increasing. An inflection at 0. Look at that. That looks really ugly. I'm going to clean it up. But there should be key ideas here. It needs to have a rel min. It has to have a rel max. And in fact, I need to have a 1, 2, 3, 4, 5, 6 is off the chart. So I'm going to go by 2s. I'm going to call that 2. Okay, so that's -6. It's -8. Okay. I'm just going to pick some nice points for my min. +2, 4, +6, 8. My max, I'm going to make it relatively symmetric since that guy's symmetric. Okay. So these are the pro moves that I don't get to talk about in lecture. And this will be some sort of inflection point. Ready, steady, go. So I'm down. I'm decreasing. Concave up. Concave up. Now I'm switching my behavior to concave down. With some arrows. Okay, now it's kind of hard to see where the concavity shift is, but you can tell it wasn't happening over here. You can tell this is nice, generally concave up. At some point it definitely becomes concave down, and I'll give you the benefit of the doubt that it happened there. Okay, same idea. First graph F double prime, then graph F. 3, 2, 1. Alright, F double prime is pretty easy. Slope undefined. Okay, now what kind of undefined is that? To me, that kind of looks like a vertical tangent. This looks like the graph x to the 2/3, which does have a vertical tangent right there. So when we did this problem in class, a lot of people were like, Mr. Leven, how can I possibly know that? How can I possibly know it has an asymptote there? And you can't. You can't really know that. Unless you know your parent graphs. Unless you know it looks like that. Okay, so here I go. Positive slope. Getting steeper, 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 steeper. Negative slope. Getting shallower, 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 shallower. That's it. Now maybe you have a jump here to here. That could be acceptable. That really could be acceptable. But I know what it looks like, and I'm going with that. Again, I can't emphasize enough. F double prime is the most artsy fartsy, feely wheely, I don't know if that's the thing, hippy dippy nonsense there is in calc. F prime has a nice algorithm. Here I go for F prime. X-intercept, right there, guys. We said squares for x-intercepts. Arrows. F prime is positive. F prime is still positive. F double prime. The slope of F prime is negative. The slope of F prime is positive. So 0 was a point of inflection. But it always was increasing, guys. Increasing concave down, increasing concave up, like that. Shift it however you like, guys. I'm going to draw it like this. And again, the goal I'm looking for, clearly concave down, clearly concave up. I had to switch someplace. I'll give you the benefit of the doubt. This has to happen at 0. It has to switch to 0. I'm sorry, but I give you the benefit of the doubt that it happens at 0. It's hard to tell exactly where it changes, but it changes somewhere. Alright, same process. Give me F double prime first, then give me F double prime. Pause it. Try it. 3, 2, 1. Okay, what's happening here? Slope starts out near 0, increases to some fabulously large number. Starts out near 0, increases to some fabulously large number. Starts out at some fabulously large negative number, increases towards 0. Good? Okay, it looks a lot like what we just did. Looks a lot like this one. But it's going to differ in terms of its final graph of f. And that's key. And that's a key. Here we go. So you should notice this is key right here. This is key for both reasons. Because it's undefined. F prime undefined. F double prime undefined. So F prime. positive to positive, F double prime, from positive slopes to negative slopes, up to down, and that was down to up. See, now you might be like, that's not a big difference, Leven. Well, you just wait. Like this. Okay. Now, maybe you draw it like this. Maybe. Maybe. But I think, and I'm going to draw it in hot pink instead. I think a more accurate reflection of this graph would be something like this. Again, I want to emphasize, you may have drawn this. There's no real way for me to critique this. Okay? There's no real way for me to do it. I can't. This follows everything we have here. Everything you know. It's quite possible that that's what it looks like. Okay? It's also possible that what we have is something close to this. It becomes perfectly vertical tangent for a minute before evening out. Because this guy, even though it's continuous, would still have a vertical tangent line there. And that's what's happening here. We have a positive infinity slope, a positive infinity slope. Right? We can think of it that way. But both graphs work. Whichever one you like best. Pause it. Same thing. F double prime first, F next. 3, 2, 1. Okay. Now, this should have a dot. I feel like I remember arguing with Daniel Murillo about this at some point. Maybe it shouldn't have a dot. Nah, it should have a dot. It just stops. Okay, so what's happening here? Positive slope. Getting more shallow. Positive slope, always the same number. What's the slope here? The slope here is always 1. So from 2 to 5, we should always have a slope of 1. 4, 5. Something like that. And before that, we should have a slope that starts off infinitely steep and shallows out. But it's always positive. It's always positive. So something like this. At -2. Womp. Something like that. I would say that slope's shallower than 1. That's the only reason I did it down there. If you didn't have the asymptote, but you just have it dead ending somewhere high, that's probably going to be marked okay. But I would say it looks very steep, almost vertical. And if it's a vertical slope, it really is an asymptote. Okay? The one I care more about. So if you didn't do this yet, try it one more time now that you saw the answer for f double prime. 3, 2, 1. Here we go. So f prime has a lot of interesting stuff going on. F prime is that point and that point as our key fixtures. It also has this point undefined. Okay? So we're going to have a -2. We're going to look at +2 for sure. And we're going to look at 3. And maybe I want some more space. Oh, I'm sorry. These should both be brackets anyway, so let's just fix that while we're at it. Why should they be brackets? Because I have endpoints here, peeps. Alright, now, up until 2. Oh, I'm sorry. It's -2. That's a bracket. That's why I got phased, everybody. Up until 2, f prime is always positive. Then f prime switches to negative, then positive one more time. How about f double prime? What's going on with f double prime? Two is again a focus. The slope of f prime is positive. The slope of f prime is positive. So it's always concave up. F is always concave up. I really should be labeling these. You should too. F is always concave up. So let's fit these guidelines on. Now, something happens here. Something important. Now, we'll have to make sure we reflect that accurately. But we'll see. Then a negative. Then a positive. They might not connect there. We'll see what's easiest to draw. We'll just try to think about it in a nice way. Up. Concave up. And see, when I join it like that, that makes sense to me. It wouldn't have a slope. It wouldn't have a defined slope there. It would just be a sharp turn. It would go from a slope of about 2 to a slope of about -1. All in one moment. Yeah, and it should start out with a slope of about 0. So at -2, we're talking about a slope of about 0. Until we get to +2. Where we have a slope of about 2. I don't know. And then we go back to a slope of about -1. And make sure you have a minimum at 3. With a solid dot at 5. You need to have those 2 solid dots for it to count. Okay, more. Always more. F double prime first, then F prime. Go, do it. Pause the video and actually do it yourselves. I'm doing it. It's been hours, it feels like. 3, 2, 1. Here we go. Alright, key points. Bam, bam, bam. All 3 of those are places where the slope of f prime is 0, 0, 0, 0. The slope of f prime is negative, then positive, then negative, then positive. Negative, then positive, then negative, then positive. Done! That's really all we can hope for. Have I mentioned yet how much I hate F prime? F double prime! Oh, I have a starting point. Erase your graph and try to do that. The next one has a starting point too. See, I knew I remembered. Alright, here we go. Did you erase it? Did you try it again? Try it. Please, for the love of all that's in the holy. Those two are key points. They're x-intercepts. So they go on my F prime number line, which slowly drifts down. Negative dose, positive dose. F prime is positive. F prime stays positive. F prime stays positive again. It really fakes us out. Just when you think it's going to become negative, it goes back to being positive. What a trooper. Now at double prime, mucho más interesante things. At negative 2, at 0, ooh, trying to line it up. And at positive 2. Positive F prime, but negative slope of F prime. Positive slope of F prime. Negative slope of F prime. Positive slope of F prime. Positive, negative, positive. Here we go. So while it's always increasing, mucho inflection things happening. Okay. So a negative slope thingy becoming a positive slope thingy. Oh, gross. I did it wrong. Becoming a negative concavity. Finally becoming positive concavity again. So this weird thing creeping up like that with a starting point of negative 2, comma, negative 2. So we're just going to try to hit that on our snaking way up. So, concave down. I faked out myself. Concave down and increasing. Concave up and increasing. Concave down and increasing. Concave up and increasing. You don't have to have it that sharp. Oh man. That's good. Just this weird thing. Okay, if I was going to get technical, I'm going to draw it again just because why not do it right once. Okay, if I'm going to get technical here, since I have more time to talk about it than you guys all care to hear, these 2 points should have a slope of 0. These two are what's known as terrace points. A terrace point. This is old school stuff, where f prime equals 0 and inflection. So it's like x cubed has, where it looks like that. It gets leveled and it's changing inflection. The force, you try to always make it. So what I'm saying is here it should look much more like this, where you can actually see it leveling off for a second, as opposed to the next one where it just flips. But then here, again, you see it level off for a second before it goes up. Something like that. Okay? It's ugly. I hate number 16, wherever on the was on the homework. It's not a fun one to do. It's harder than what they usually give you. But reading this is so good. If you do all hour or however long I've been talking for of this video, you'll be so good when we do FRQ stuff. Oh man. This one will have a starting point. Look, there's a starting point. Pause the video here. Try out F prime. Try out F double prime. 3, 2, 1. F double prime first. Very important. But more important, the slope of F prime is always 0. Okay. That hole is very important there, though. Make sure you have that hole there. Okay, that's it for F double prime. F no prime. Gross. Give me the color I want. Important. Double important. F prime needs to have that as a critical number, because F prime goes from being positive to negative at that point. F double prime needs to have that. I'm so sorry, that looks so awful. The slope of F prime is 0, and then it's 0. Womp, womp. What kind of concavity? You must always remember 0 concavity means straight line. Wow, I can't spell to save my life today. Straight line. Start 0, 2, right there. What's that slope? Oh, sorry. What's that y coordinate? 2. Negative 2. Something like this. I'm going to check. See, the slope is negative 2. The slope is 2. Something like that. That's what it's supposed to be. Okay. Now, the last one. The last one? Yes, the last one. Oh. Blank page. Sketch a graph of F double prime. Sketch a graph of F. 13 first, please. Starting point. 3. Pause it. Try it. If you haven't tried anything else in this video, try this one. 3, 2, 1. Okay, here we go. Important. 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 Why? Because each of those has a slope of 0 or undefined. That one's the undefined one. I'll think about what to do with that later. You're watching me solve these live. I don't have these solved on a separate sheet of paper. Sometimes when I'm pausing it, spoiler alert, I am thinking about it extra. But most of the time I'm getting a drink of water because I'm pretty parched even right now. But I'm going to try to finish this. 3. X equals 3. Slope of F prime. Slope of F prime is positive, negative, positive. Okay. Positive, negative, positive. Okay. What's happening at 3? No, what's happening at 4 is the question. It has a sharp turn where the slope of F goes from being some positive number very quickly to some negative number. And the fact that negative number is 1, 2, 3 down. So we're just going to have a dead end. And then it's going to become negative 3. And go to the right. Oh, I guess it stops. See, there's no sign of stopping. So probably should have a solid dot there. And that's right. Nothing else is right. It needs to have a jump there. Sharp turns like that usually turn into jumps. Okay. We'll go back and add that on to the first slide. Let's just knock this one out, right? Alright. Okay. F prime. Number line. Arrow on the left. Bracket on the right. X-intercept. X-intercept. Not a hole. An asymptote. Be fine. 0. 3. F prime's negative. F prime's positive. F prime's positive. F double prime. Wow. Straight lines. Bad. Not 0. 0 is fine for F double prime. For F, yeah, so that's a 1, 3, 4. Okay. Slope of F prime is positive. Slope of F prime is negative. Slope of F prime is positive. Slope of F prime is negative. And that sharp turn is going to funky up maybe a bit. We'll see. Down. Increasing. With the fake out to be increasing. Okay. Concave up. Switching to concave down at 1. Switching back to concave up at 3. Switching to concave down at 4. It should be a little bit sharp there, but not anything crazy. Okay, so containing the point here. So this has to be our minimum. Concave up. Concave up decreasing. Concave up increasing. Up until 1. Concave down increasing. Up until 3. Concave up increasing with a terrace point there. Concave down increasing with the dot. That's good enough. Should be smoother. Just like that. So I'm going to go all the way back to the beginning just to add more to that table that you hopefully copied down. Over here, you're looking out for x-intercepts, discontinuities. Holes. vertical asymptotes. Okay. Jumps. Here you're also looking for sharp turns. Or vertical tangents. Alright, if you watch this whole video, congratulations. Mostly I want to give my congratulations to the people who actually tried out all the problems. Good on you. It's really impressive that you're doing this much math outside of school, that you're willing to listen to this whole video and give it your attention. I hope you give it your attention. I certainly spent my time on break doing this, so I appreciate you. You appreciate me, right? Okay. Like and subscribe if you appreciate me. I'm so pathetic. No, but you guys have a great day or a great night, and I'll talk to you soon. All right. Bye-bye.